shellfish eaters mostly. They use these for crushing shellfish.
But you see them in fishmongers, but they don't look the same. I mean, you're seeing it in the real world. Yeah, it's fabulous.
Have a good sniff.
Come on.
1, 2, 3.
It's learning in the real world, effectively. It's actually taking the classroom and placing it on the oceans and being able to actually see oceanography in action.
The research vessel Callista is on a voyage to introduce more schools to marine science. These Year 9 students from Sandown High School on the Isle of Wight are on the verge of choosing their GCSE options. Will the Discover Oceanography programme inspire them to choose science?
A lot of the time they come along with a pretty open mind, really. Whenever possible we try and get the children to handle the samples that we've collected. So you slap somebody a spider crab in their hand that completely fills their palm, that just takes their breath away. You know, they're really quite amazed by it.
The layers within the sea contain lots of animal and plant life, but plants need sunlight to carry on photosynthesis. Heading out to sea, the class gets stuck into the first experiment to see how far light travels down into the water.
What this does, this instrument, is it allows us to estimate the depth of light penetration into the water column. Okay, in simple terms, what you do is you lower it down into the water like that until it just disappears from sight, okay? When you just can't see it anymore, the light has gone down to the disc, bounced off the disc and come back up to the surface, okay? And that light has just disappeared from your eyes. It turns out that 3 times the distance at which this disc disappears from sight, i.e. 3 times the Secchi depth, will be the same level in the water at which the light has fallen to 1% of what it was at the surface, or 1/100th of the surface light level, okay? So what we can do, we can drop this in quickly, measure the distance from the water surface down to the disc, times that by 3, and that will give us the depth of light penetration. Now, why do you think that's important? Anyone got any ideas?
For like stuff that grows in there?
Yeah. And plankton are microscopic plants that float around in the water. Okay, and they need the sun's energy for photosynthesis. And below the light penetration depth, there isn't enough light basically for them to do that. So don't spend too long over it. Once you think it's gone, it's probably gone. Okay, and just pinch it off where it's at the railing here. Do you reckon it's gone there?
Yeah.
Okay, we'll pinch it off there. So the Secchi depth, 2.5 metres. Okay, now what did we say for the light penetration depth?
Times it by 3.
Yeah. So that means that at this location right now, the light at 7.5 metres has fallen to 1% of what it is at the surface. But what we've got here is quite a low reading, and that's because if you look at the water, there's quite a lot of sediment and murk in it. There's rivers coming down from Southampton. There's a lot of tide whistling up and down there, which is churning up the sediments, which is getting quite a lot of particulate matter into the water, which is attenuating the light.
More than 1/3 of the world's population live on or near the coast, so estuaries like Southampton Water are an ideal place to see how human activity impacts on the oceans. The pupils are about to learn some basic ecology.
Fish. I know, but what is it? What tide? Fish. You right, Charlie?
Quite amazing creatures. As you can see, they change colour. And they actually communicate with each other by changing colour. Yeah, you can have a quick touch. Be very gentle with it.
It doesn't like me, does it?
Just watch out for the tentacly end because they have a big beak in there that they use for crushing up crabs and things. Yeah, that squirt of water is it's one of their ways of moving.
It's all slimy.
And if we look here, the reason we've got a lot of cuttlefish here at the moment is because they're all coming in to spawn. And those are the eggs of the cuttlefish.
Really?
Yeah, so you can pass those round.
Oh, that's the stuff we pop on the beach.
This is the other fish we caught. Let's put some water in there with it. It's like a skate. It's actually called a thornback ray. Thornback ray, that one. So these are close relatives of sharks. It's actually a small flat shark, really. These are the eyes on top, and these are the gills. This is the mouth. These are shellfish eaters mostly. They use these for crushing shellfish.
This is not the most amazing thing you've seen today,
Yeah.
isn't it?
I
I mean, to see these things here. Well, you see them in fishmongers, but they don't look the same. I mean, you're seeing it in the real world. Yeah, it's fabulous. Absolutely brilliant.
And it's a great way of showing them that there is life beyond the textbook. I mean, the textbook is a very narrow area to look at, and these guys can see all of this for real, up close and personal. Well, we do the 21st century science curriculum, and that's physics, chemistry and biology based. And it's nice because these guys can now sort of put it into context of the land-based work and also the marine-based as well. And it's important that they find out that we've got food chains and food webs at sea as well. And physics works on both and with the currents and the tides.
What do you notice about the seaweed?
It's different colours.
Right, 3 different colours. Any idea why? Absolutely, different levels. Why would it be a different colour at a different level?
Because there's less light.
To do with the light, yeah. It's actually the different wavelengths of light, that's the different colours of the light, are absorbed at different rates as it goes through the water.
How much have you got? A little bit. I'll eat it. Go and get a bit. Oh, it's free. Go and eat a bit. Seaweed. 1. That's free. 2. Free. Seaweed. Oh!
It's very good gift. Minerals, iodine, salt, good.
Food for thought, but the ocean's productivity depends on the tiny plants and animals at the base of the food chain. The answer's clear as mud.
Right, before you touch it, have a look at this lighter area on the surface. Now, this is the oxygenated layer. Now, you can see it's a different colour. As you go down, so it gets darker, there's less oxygen in these lower levels. Now, did you find any shells on the surface at all? Okay, let's now just pull this apart. So effectively it's collapsed in on itself. This is actually the surface here. Now here you can see some tube worms. Okay, so they're filter feeders. Grab hold of a piece of this mud.
You guys want to get some?
Come along, get some mud in your hand. This is hands-on oceanography here. No one gets away with it. Have a good sniff. Go on.
Lovely.
Does it smell horrible?
No.
It doesn't smell horrible, does it? Okay, there's grit in there. That's effectively, that's your history lesson from the mud. Now, if this were polluted and nasty, then you generally wouldn't find many creatures living in here. That if we were to sieve this, here we would find a good amount of top shell. As the top shell break down, they die, they go with their normal life cycle, their shells are left behind. And the shells break down into smaller granules. So that grittiness you can feel at the top shells from years gone by to show that this has been healthy for many, many years. There you go, someone do some sieving, so put that in there. Now we want to get all of this mud through the sieve as much as possible, but obviously we want the creatures that are in the mud to stay in the sieve. We have a ragworm.
Where? Oh, yeah,
That one's a ragworm.
Don't ragworms bite?
They do, yeah.
Would that one bite you?
Oh yes. What we'll do, we'll then take this and look at it under the microscopes.
some of the things we sieved out of the mud. So that's one of the worms. So all the way down the side it's got these sort of like paddles, and they've got a clump of bristles coming out of each paddle there, and they actually use those to help them burrow and swim. The more species there are, generally speaking, the healthier we consider the environment to be. So just in a couple of minutes of sieving there, we've got these 2 different species of worm, and also these juvenile shellfish. A little tiny clam there. Anyway, we'll have a look at some of the plankton now. But it's all the plants and animals that drift on the currents. So they tend to be mostly quite small. They form the base of the food chain in the ocean. That is a juvenile copepod there in the middle. And the copepods are what we call holoplankton. They're zooplankton because they're animals. And copepods are herbivores, so they're actually going to be grazing on the phytoplankton.
Those are single cells?
Yeah, single plant cells, called diatoms. Now that beastie there, that's an absolute beauty.
Mosquito.
It looks a bit like a mosquito, doesn't it? If you notice, it's got this really long spike on the front of its nose there.
It's got blood on it.
You're very, very close. It's a crustacean. It's actually a crab, a kind of a crab called a porcelain crab. And notice it has this long tail, which you don't see in the adult crabs, because that tail sort of tucks underneath and becomes part of the body.
One of the things that we try and do is show them that although we're doing this to some extent in a fairly high-tech way on the boat, some of the equipment we've got is very expensive, they're not going to encounter it normally. You can do very simple experiments with some very, very basic equipment. You can take a sample of mud and sieve it through a sieve that you'd find in your mum's kitchen at home. We want them to go away thinking that science can be fun, that going to university is a career choice. Universities aren't full of boffins, they're full of normal people. Hopefully they'll have learned something about the environment which they're part of, what's on their doorstep, and they'll have had a good time as well.
The Discover Oceanography team is determined to capture more than samples. They want the next generation of ocean and earth scientists. Has today's hands-on approach given the pupils a taste for the sea?
I thought it was going to be boring, but it really wasn't.
I wasn't expecting to be on such a big boat.
Yeah. It just shows that even in 3 hours you can learn quite a lot. Like to become a scientist, it probably wouldn't take that long.
A lot of people think that you need a lot of high-tech technology and everything, and but really all you need is just a bucket and a spade, and you can learn a lot from just experimenting.
I didn't realise how many different species and everything there were. When you get deep down, they're so tiny.